Right. So Oddlib is a tool for generating application-level audit data. And a good first thing to know is, what does it mean to audit a program? So when you audit a program, you're examining some information about what the program is doing. And some examples of the information that we might be concerned with are the name of the user running the program, the name of the program itself, sort of a list of the files the program has open, and what it's doing at any given moment, whether it's accessing something or waiting for the user to give it some input. And Oddlib is designed to capture this information. And it has a few different goals, which includes providing application-level audit data for computer security purposes. And you also want it to integrate seamlessly with other applications, and that's important, as anyone who's used a computer running an antivirus program knows. You don't want to have to wait for the antivirus program to do something. You want to just be able to open a program and go with it and not have to worry about what the security programs are doing in the background. Also, Oddlib is capable of gathering a large amount of data from any given program, so you want to make sure that it's easily customizable, so you can trim down the amount of data that's being generated at any given moment. Oddlib is designed as 3 independent interposing libraries that each have a separate focus within the security world. And then there are some common routines that deal with actually logging the data that Oddlib brings in and doing some initialization for the program itself. Now, you might wonder what an interposing library is, and in order to understand that, we have to look at sort of the anatomy of a function call. Say you have a program and you want to know what the square root of something is. You're not going to write a square root function. Someone has already done that for you. You're just going to ask for the square root of the number and assume it'll come back to you. But in reality, what's going on is your program is communicating with the system library stored somewhere on the computer, and the system library is doing the calculation for you and returning a value. When you're interposing, there is another step in the middle, and that's what Oddlib is doing. It's inserting itself between the function calls coming from the program and the system library, and it's using the arguments passed into the function to generate the audit data. For instance, what we're taking the square root of in this case. And then it's storing that data, passing the arguments onto the system library, and returning the value back to your program. So as I said, there are 3 different libraries. The first is dealing with different attacks, and that means detecting when programs have been affected by worms or viruses. This means dealing with sort of common exploits used to take over computers, like buffer overflow attacks, format string attacks, race conditions. You don't have to know what those are, it's okay. But the idea is that it's dealing with sort of standard security virus kinds of things. The second library is called intrusion, and that's dealing with people who are gaining access that they shouldn't have, and that could be, for instance, someone in China who's trying to hack into your Gmail account and steal your credit card information, or it could be your 10-year-old child who you don't want to have access to the internet. Either way, Oddlib looks at the commands that each user is executing, and that would allow a security program to build sort of a user profile that could detect when anomalous actions were occurring and when a user was just doing something normally. But Oddlib is just concerned with tracking the program usage of each user. The third library is called misuse, which is concerned with people abusing authority that they have legitimately. For instance, you probably have a system administrator that takes care of your network. That person has the power to read all of your emails, but you generally assume that they aren't going to do so unless they have a good cause. And in order to detect that sort of behavior, Oddlib watches all functions that can potentially modify or access any file on the file system. And that's a lot of information, but it gives a really complete picture of what each user is doing down to what portions of the file they're actually looking at. So that can generate really good information if you're interested in that. I said earlier that Oddlib was designed to be highly configurable. Some of the things that it can do are specify what functions are actually being logged. You might be more concerned with certain types of attacks or certain types of misuse than others. and the configuration file will let you easily trim down what information is being collected so you don't have to sort through everything in order to find what's important. The configuration files also let you specify what happens if something bad comes up. If Oddlib crashes, if the program crashes, what do you want to have happen? Should it print something to the screen? Should it just try and continue without stopping, or should it exit and close everything down? And forthcoming in the next week or so, the configuration files will also be able to specify what programs are being interposed. So when you start a program, Oddlib will be able to look at it and say, oh, you started Internet Explorer, I should watch this. This is something that's important. Or it can say, oh, you started a calculator, I don't really care about this, you can do whatever you want with it. And it will also be able to specify where log files are stored, what it actually does with this information, so you can potentially protect it from being visible to all users and put it somewhere secure, or you can make it easily visible to anyone who's interested in the information. One of the other things that was supposed to be happening this summer was benchmarking, which is getting an idea of how much overhead the audit process is generating. Unfortunately, this has been delayed for several weeks because of some difficulties. Oddlib was originally written on a 32-bit platform, and when we moved it to a 64-bit platform to do the benchmarks, a lot of things broke. And a lot of that has to do with people not making sure that data storage containers are big enough when passing data around, when we're logging things, and using improper formatting when printing data out and in order to actually log it. Another big process was trying to get Oddlib to play nice with the Linux boot process. And in the end, we were sort of forced to accept that the Linux boot process is a little bit strange and we probably shouldn't be interposing function calls during that time, especially while the file system is read-only, because we can't log data because you can't write to the file system. Another big problem has been with programs that are deemed particularly vulnerable to attack, and so they get placed in sort of a special jail where they can't see the entire computer. They can only see the files that they need to access to perform their job. Typically, some portions of email servers are jailed in this manner. And what that has done is it doesn't let Oddlib see where to put the logs, and it doesn't let Oddlib see where the actual executable file is, and that stops it from gathering information that it would normally look for. So future work is concentrating on creating more configurable options, not logging our own function calls. That's kind of important. You don't really care what Oddlib is doing, you care what the program is doing, so you want Oddlib to really be transparent to itself. Increasing stability, which goes back to dealing with the Linux boot process. We want to make sure that Oddlib doesn't cause more failures than it prevents. And ideally, we'd also like Oddlib to be able to be used on systems that are more than just Linux with certain extensions, and that means doing more self-configuration when we actually go and build Oddlib, and making sure that we have certain functions on the system where we can work around not having those functions. I'd like to acknowledge Ben Cooperman, the Overland Computer Science Department, and if this sounds interesting to you and you want to get a copy of Oddlib for yourself in a week or so, go to that website. It'll be available for you.
Questions for the speaker?
So this is a little more specific than you were getting, but how exactly does Oddlib work? Like you run Oddlib and then it tracks system calls?
It tracks function calls and then it stores the arguments in the function calls to a file.
Okay.
So
There's a functionality in the dynamic loader that allows you to say, look here first before you look in your normal place.
yeah,
Well, look at us first.
there's an environment variable that you can set, or you can there's a global file that the dynamic linker will check
Right.
to see if it has anything in it, and you can put the Oddlib libraries there, or you can set the environment variable. And there's some scripts provided in Oddlib that make that a little bit easier.
So it seems like your average Internet Explorer program is going to have bazillions of function calls
Yeah.
that you're all tracking.
Yeah.
How do you decide which ones are good or bad or dangerous or something?
That deals with what happens during common attacks. There are certain functions, this is all dealing with C. If you're in a different language, this isn't going to help you. But there are certain C functions that do...
So you flag string compare or something like that?
Yeah, things like that. String copying, opening a file, closing a file, accessing a file, changing permissions on a file, things like that.
So you're intercepting the operation calls before they reach the system.
Yes.
Does that provide the overhead involved in that? Does that significantly lower the performance of any program that might be running like Internet Explorer?
In the limited tests that I've been able to do without a nice commercial benchmark, not really. It seems like things go a little bit slower. Certainly, the more that you're trying to do at one time, the slower it gets. Some of that may have to do that I'm running this on a reasonably powerful machine. It can certainly generate a lot of data, like maybe 50, 60 megabytes in a minute if you're really hammering the system, but it doesn't seem to slow things down particularly noticeably.
This is sort of an odd question. I keep hearing Internet Explorer and Linux.
I just chose Internet Explorer as something that we associate with security vulnerabilities.
Okay, let's thank all the speakers for this.